Hello, how are you today? My name is Dr. Bray.
Hi, I'm not doing so well. I think I'm dying.
Why do you think you're dying?
I can't feel my right arm or my right leg. I think they're paralyzed. They're very limp. Also, I'm mixing up my places and my objects. I was going to the hospital earlier, and I told my friend I was going to the grocery store. It was weird.
When do you think these symptoms started?
When I woke up, probably around 7 a.m., like 4 hours ago.
Did anything traumatic happen this morning? Like, did you get in a car accident? Did you have any type of head injury?
No, had a pretty normal morning.
Okay, well, I'm going to go over your past medical history. Do you have any history of stroke in your family, or have you ever had a stroke yourself?
Mm-mm.
Do you have a history of epilepsy, or have you ever had a seizure?
Yeah, I am epileptic, and I have seizures most mornings when I wake up. I had one this morning around 6 a.m. Do you think that could be related to my symptoms?
I do. I'm going to run some tests to prove my diagnosis. I'm going to run an MRI to make sure that you have no brain damage or a blood clot that could make me think that you might have had a stroke. I'm also going to perform an EEG test to study your brain activity. But first, if you could look up and try to look at the light. Follow your eyes with the light. Okay. And is there any way you could tell me what this object is?
Banana.
Okay. And is there any way, is this the side that is feeling limp?
Yes, I can't feel it. Can't feel anything.
Okay. Can you pull towards yourself away from me?
I can't move at all.
Okay. Okay, so I got your results. Your MRI came back normal, which rules out any stroke. I didn't see a blood clot. I didn't see any kind of brain damage.
Good.
But your EEG, however, shows some slowing of your cerebral hemisphere.
Uh-oh.
It was contralateral to your paralysis, so the slowing was in your left brain because the right side was the one affected. The slowing consisted of a higher amplitude and a lower frequency of the excitatory and inhibitory potentials. From these results, I have concluded that you are experiencing Todd's paralysis.
What's Todd's paralysis?
Todd's paralysis is a muscle weakening or paralysis after a seizure. It occurs in the postictal period, which is like your altered state of consciousness. It's hemiparesis, meaning it affects the body unilaterally. So if the left brain is affected, your right side is the one that's paralyzed. So that's in your case. Your left brain was affected. The paralysis can last from about half an hour to 36 hours. Usually the seizure in this case has affected the motor cortex and the cerebral hemisphere, which we can see in your EEG. However, other effects can occur. Sensory changes can occur if your sensory cortex is affected by the seizure. Vision is affected if the occipital lobe is involved, which applies in your case. When I shine the light in your eyes, I could see a type of eye gazing. Your inability to use correct words for objects and places is known as aphasia, which results when speech and comprehension fibers are involved.
What causes the paralysis?
The cause of Todd's is unknown, although several hypotheses exist. One hypothesis is the depletion theory. So when you usually have seizures, it means you have an imbalance of excitatory neurotransmitters. In this case, it's glutamate. So the depletion theory states that you're exhausted. The neurons are exhausted because so much glutamate is being released. The EAAT cotransporter can't take the glutamate out of the synapse fast enough. Therefore, these NMDA receptors are overactivated. A previous depolarization causes this receptor to open. Sodium and calcium influx in and potassium comes out. Also, because of this depolarization, magnesium pops out of the channel. Because the receptors are being so overactivated, the calcium is influxing at a high rate. The calcium can generate free radicals, which are very harmful to the cell. It can disrupt cellular function. The calcium also goes into the mitochondria, disrupting the membrane potential. So any loss of membrane potential results in no ATP production, which ultimately leads in cell death. Another hypothesis says that the motor centers are inhibited. In this case, so much glutamate is being released, but eventually the glutamate is depleted. Because there's no glutamate in the synapse, the NMDA receptors are inactivated. You can see the sodium and the calcium are outside the cell, and the potassium is still inside the cell. You can also see the magnesium ion in the channel still. Because these receptors are closed, no ions can flow in, therefore no graded potential occurs. And then because of this, no action potential occurs. And communication is prohibited, therefore no movement can occur, ultimately leading in the paralysis. So another hypothesis says that the paralysis happens because of vasomotor changes that occur during the seizure. An example of these changes are arteriovenous shunts. Normally, blood flows through arteries into the capillary bed, where oxygen is transferred from the blood to the cells. Blood then travels through veins to the rest of the body. The brain is one of the regions in the body that receives this blood. However, if a shunt is formed during a seizure, the blood can't go to the capillary bed to receive oxygen. Therefore, there's a reduced blood flow to regions of the brain that ultimately causes a paralysis.
Is there anything I can do to fix this or take to fix my paralysis?
Well, the symptoms don't usually last long, therefore no treatment is given. The condition will resolve quickly on its own. Usually there's an average of 15 hours that the paralysis occurs, but we haven't really seen a case where it was past 36 hours, so you should be fine.
Okay, good. Thank you so much, doctor.
You're welcome.
Have a nice day.